All right, the second half of the lesson is polynomial functions, day 2. This kind of shifts gears from where it finished up the last lesson where we plugged in function. This talks a lot more about the graphs. Okay, and it's more of a knowledge day. It's not really too much computation. You're not going to take a whole bunch of notes, but you definitely need to be paying attention. Okay. To start, all right. Now you can kind of quickly draw this. I want to say, I think this is on 3. I want to say 330. No. 324. Okay. If you have your iPads open and not to my PowerPoint, open them up to your books on page 324 because that's where we're going to be pretty much all day. All righty. Okay, 324. Let's start at the top row. That's all stuff we know. The first graph here is a straight horizontal line, which means you have the line y equals. Okay, y equals some number. This could probably be y equals 3. All right, because it's up here. So this is probably something like y equals 3. All right. The second one, what type of function? Linear. Okay. And when you write a linear, the most common form is what? Starts with an S. What is that? Most common form of linear functions is slope what? Intercept. Slope intercept, which is y equals mx plus b. All right, so I'm just going to take a guess on what this one could be. It's not going to be exact. Let's say it's y equals 2x plus 4. All right. What's this third one called? It's a quadratic, all right, and its big feature is what? What's the big difference between quadratics and linears? Not the graphs, the equations.
What is that called?
What's the major difference between the equations of quadratics and linears? Okay, if you think back to chapter 4, the definition of a quadratic function had some...
It's 3 terms?
It's 3 terms, but the biggest...
The equals on.
Nope.
X squared?
Say it.
X squared?
It has exponent of 2. Okay, so this one could conceivably y equals negative x squared plus 2x plus 2. All right. Now, let's stay there for now, okay? Let's stay there for now. Kind of ignore this one. All right, just remember it's a constant. You have a degree of 0, okay? Now remember what degree means. Degree is your what? What's a degree? The biggest exponent, all right? This one's a degree of 0 because it doesn't have an x. There's no exponents. Okay? Linear has degree 1, right? Because it's got 2x plus 4. Quadratic, degree 2, y equals negative x squared, blah, blah. All right? Everybody good so far? Okay, now, go down to the bottom row. A cubic function has degree of 3. So I'm not going to go too terribly into making up what it could be because it's just going to keep getting longer and longer. So I'm just going to kind of write it y equals x cubed. Make it actually look like a cube. And let's just say it's minus 2x, whatever. All right, probably isn't, but it doesn't matter. What similarities do you see between this graph and that graph? Rainey.
It has 3 kind of different. I don't know if it's not favorite lines, but it's going 3 has 3. 1, 2. I don't know how to explain it.
Okay, it's a little tough to explain. All right.
It's cubic and it goes 3 different ways. I don't know.
Miss Dixon. Similarities between.
They both go the same direction.
How so?
Because, they both go down and up. The only difference is that one goes up, it comes backwards.
Okay, what about like, you're on the right track though, towards the ends though, they both what?
Or they never end.
Like, well yeah, but this end keeps going which way?
No, up.
Up. And this end keeps going up. This end keeps going down. This end keeps going down. Okay, let's throw what Sullivan sniped out there. What about 5? Throw 5 in there. This one keeps going up, and this one keeps going down. All 3 of them, as Sullivan said, they go in opposite direction. Their ends, one end goes up, one end goes down. See that? On all 3 of them, the first, the third, and the fifth. Okay, now, those three numbers I just said, 1, 3, and 5, they are all what? Odd. All right?
So,
Easily?
like second is the hard thing at the hospital.
Yeah.
Is this what they using to figure out the heart?
Deep down into the program, probably. I don't know for sure, though. I couldn't tell you. It looks like it, though, doesn't it?
Yeah.
Okay. But deep down into the program of those computers, I don't know. Okay. Now, real quick, let's extrapolate this a little bit. So this is the first degree, this is the third degree, this is the fifth degree. What about a seventh degree? Would they stay constant? All right, would those properties stay true in a seventh degree polynomial? More than likely, right? You see the pattern, right? Okay, your odd degree, 7 is odd, so they go in opposite. Your ninth degree, they would go in opposite directions. Your 11th degree, okay, they would go in opposite directions. That's a quality that is true among all odd degree polynomials. Okay? Every single odd degree polynomial points in opposite directions. So whether it's a linear, a cubic, or a quintic, you don't have to know that word, but those are the three main ones you'll be working with. All right, these three here. Okay? Ignoring the constant because it's kind of all by itself. Let's go to the even ones, 2 and 4. What's similar about them? Okay, let me give you an equation for the quadratic function, though, just so we can kind of talk about it. Let's say it's y equals x to the fourth, make it easy, plus 6. What's the similarity between the two, degree 2 and degree 4? This one here and this one here. Mr. Flynn? Symmetrical, all right, I like that. What else? Symmetry. Okay. What else?
Will that always be constant?
What do you mean?
Like, will they always be symmetrical?
I believe so. I'm trying to think of one that's not. I think so, though.
Another question.
Easily?
So, since those arrows are pointing down,
Yeah?
and then them arrows are pointing up,
Yeah?
does that mean those two outside lines just came from the arrows pointing down, and then just went up? So it started from the
You point at 2?
x-axis?
Your
Or
point.
we started at the x-axis?
Okay, yeah, kind of. You're on the right track, all right? But you have to think about it like this. You don't start it from the x-axis, right? When you read a graph, you read it from left to right, right?
Yeah.
Okay, so if you're like thinking about it like that, and you're like reading this graph, okay, the quadratic function starts way down here, it goes up, and then it comes back down, right? You think about it kind of roller coaster-ish. The fourth degree starts way up here, goes down, comes back up, goes back down, comes back up, and keeps going up. Okay.
So
One more guess. What's the major similarity between the quadratic and the fourth degree? Thinking about what we talked about with the odds. Okay. Think about what we talked about them and the way their arrows pointed. They go the same direction. Mr. Flynn, very good. All right. If you look at the quadratic term, the one, they both point down. If you look at the fourth degree, they both point up. All right. All even degree functions have that similarity. Okay, they all point either up or down, both ways. Okay. Odds, just because we didn't talk about it, odds can conceivably also go like that. All right, there's something that makes them go like this. Okay. But we'll get to that in the next slide. Now, I purposely wrote the quadratic function up here and the fourth degree function down here. This function both point up. This one both point down. Why do you think that is? Okay, Miss Dixon. The negative up here. Very good. Okay, which should hopefully, if not be common knowledge, hopefully bring it back from chapter 4, right? If it's negative, it's pointing down. This one's positive, so they're pointing up. They are all like that. Okay? So there are similarities across the board of all of your polynomial graphs. Okay? What you're going to be tasked with today, I don't want to say it's memorization of those qualities, but it kind of is. All right? It kind of is. Now, the bottom of that page, what did I say it was? 324, is that right? Okay, the bottom of that page kind of makes this, has this chart on it. Now, for you guys, there's a few things up here you don't need to know, so I'm going to cross them out right now. All right? First thing is the end behavior as it's written up here. Okay, we're going to talk about end behavior of each of these graphs. We're just not going to use arrow notation and infinity signs. Okay, so you can cross all of those out. Staying true with everything else, we're not really going to worry about domain and range until we get later on this semester, so you can cross that out. Okay. What you do need to know, all right, and like I said, this isn't too many examples, this is more conceptual in your heads. What you do need to know is if you have an even degree and a positive leading coefficient, what kind of graph does that look like? Specifically, the ends. Okay, and they both point up. All right, that'd be a great answer if we were third graders. All right, they both point up. Yay! Okay, we're a little more sophisticated than that, not much, but a little. All right, so we're going to talk about it just a little bit differently. All right, so that's what we're talking about with end behavior. Oh boy, where am I going to put this? It's going to be kind of crammed. All right, I'm just going to squeeze this in as best I can. So we're going to talk about the end behavior. All right, now we're going to talk about it in two different directions. Okay, the first direction being as x increases. The second one being, as x decreases. Okay, this is going to be ugly and awful, all right? Now, you're talking about the numbers on x's. Okay, so x is increasing, x is decreasing. All right, the question basically is, as x increases on the first one up here in the top left, as x increases, what does the graph do? As my x's keep getting bigger, where does my graph go? Up. Or another way to say it, the graph also does what? Increases. Okay, remember we're getting older, we're sophisticated with our words. Increases. All right. So as my x's keep getting bigger, my graph is getting bigger. As x is increasing, my graph is increasing. Go the other way. As x is decreasing, getting smaller, what's my graph doing? Increasing still, right? Still going up. Okay. Sorry about the clutter, but I should probably split these up into 4 slides. Every single even degree with a positive leading coefficient polynomial has that similarity. Okay? Now, you notice if you slide back, if you're on your book, slide back up. You'll notice that in the middle, in between, like if you look at your 2nd degree and your 4th degree, there's a whole lot of nonsense going on in between the ends on the 4th degree as compared to the 2nd degree. This isn't talking about the middle stuff, all right? So it can look like someone's having a heart attack, all right? Or, heart's beating pretty quick in the middle, kind of like that 4th degree one. You don't care about in the middle. You want to know the ends. You care about the arrows, which way they point, basically. All right? Make sense? So every even degree with a positive leading coefficient has these end behaviors. Okay? Down here to the second one. Even degree, negative. So as x, I'm going to start right now, NC and DEC, okay? So as x increases, the graph does what? So as x is getting bigger here, what's the graph doing? It's decreases. See how it's going down? Okay, the graph decreases. Okay. As x decreases, what's the graph doing? Decreases as well. Okay? And remember, for even degrees, those arrows always point the same direction. So for even degrees, these two words here will always be the same, whether it's increase or decrease. Okay, Ron?
I don't get the increase, decrease back. When?
Start your origin. Okay? If you start at your origin, which direction is x increasing?
Nowhere.
Nowhere. If you start at your origin and you move, let's put it like that, which way does your x increases? From here.
To the right.
To the right, right? They get bigger this way.
Huh?
Here's the origin.
Yes.
That's what coordinate?
0,
0,
0.
0. What coordinate could this be?
Wait, what?
Right there.
Where your arrow's at?
Yeah.
Maybe like 0, 3?
Flip it.
3, 0?
3 0. I got bigger, right? Over here, maybe like 5 0, 6 0, 8 0. They get bigger this way, right? So this is the way x is increasing. Conversely, that's the way x is decreasing, right? Now, I ask you, which way is the graph going? So as my x's get bigger, my graph goes where? Keeps going down. Keeps getting smaller, keeps decreasing. So that's why you write it like that. As x increases.
If you go to the right and then down. Oh, there's negative.
Okay.
So then up top is because it keeps
Going up. Correct. Correct. Okay. As your x's get bigger, which way does your graph go? So x's go this way, your graph's going up. As x goes this way, your graph's going up. As x goes this way, your graph's going down. This way, going down. Okay.
So will we always have an x increase?
Yes.
Decrease?
X increasing and x decreasing are always your first two comments about the end behavior itself. Okay. And honestly, then you can put the graph blank blank. Okay. Your first quiz, whenever that is over this, I actually write this out for you. I say as x increases the graph blank, as x decreases the graph blank, to get you used to the notation just a little bit.
You gonna put that on the
Yes.
wall?
Not tomorrow. It's not there tomorrow. Okay. Chamberlain.
So, but like, if I went over to where it's going up and down,
Mm-hmm.
as increase, you said the graph will increase, and when the decrease, and then the decrease.
Correct. You always just go with whatever is there.
Oh,
Okay, so that's where I don't want to say it's straight memorization because I don't want to be like, okay, here's this, what is it? Go, right now. Because it's not. As long as you can read the graph, you can figure these out. Okay? And as long as you understand what you're doing. That's why I said today's more conceptual than it is computational.
But it looks more complicated.
It does. It looks a lot more complicated because these graphs are a lot busier than what they really need to be. Okay? So, I'm going to write, with that in mind, I'm going to write out those two. Alright, so the first one here, the odd one, as x increases, the graph, which way is it going, Ron? Up or down? As your x is getting bigger, as your x is getting bigger, as x is getting bigger, where's my graph going? Up. Alright. So as x increases, the graph increases. As x decreases, the graph decreases. Okay? And then the other one, I'm not going to write there because I'm kind of out of room. As x increases, the graph what? Decreases. As x decreases, the graph increases. Okay? Now, here's the trick though. The odd ones, evens point same direction, whether that's up or down. But they're always the same direction. Alright? Odds always Odds always point opposite directions. The key is to figure out when it's positive, when it's negative. Okay? If it's positive, it's going to be overall increasing. So it's going to be going up from left to right, which makes this one positive. Just like a line, right? Just like a line. So it's going up from left to right. This one's negative because from left to right it's going down. No matter what happens in the middle. Okay? Chamberlain.
we have to, so When you were showing those functions on the previous, you have to do that.
You'll have to, yes, you'll have to do this. You won't have to tell me their names. Okay,
But
so
you
you,
just have to say if they increase or
Yes.
decrease.
yeah, we're going to do an example here in a little bit.
Okay.
Okay, what I expect. All right. Last topic before we do an example and kind of sum this whole thing up are the zeros. Zeros of even and odd degree functions. Okay, now think back to chapter 4. What are zeros? No. Zeros, not zero.
Chapter 4 zeros are.
Okay. We did two words in chapter 4. One was roots, the other was zeros. Roots were your equation answers.
Oh, it has to equal 0.
Zero are where you cross the x-axis. Okay, the x-axis. All right. And think back to chapter 4. We had 3 different situations. How many solutions? Okay. I quizzed you on this like 3 times.
All real.
Okay. Ease.
Oh,
We had 3 different situations. It was
all reals.
nope.
No, yes it was. It was all.
No, was it? I remember now. Isn't it one?
One real root.
Yeah.
What's the other 2?
No real.
No real roots or
And 2.
2 real roots. Okay. Those 3 are zeros. Okay.
Did we have to put root? I don't remember.
Yeah, no. Now, the reason you had 1 was because it touched the x-axis and it counted it as 2. It repeated itself. Okay? But basically, you either had 2 or 0. Coming from a quadratic function with even roots. Basically, what that box says up here, if you have odd degree functions, you will always have an odd number of zeros. If you have an even degree function, you'll always have an even number of zeros, or no real zeros at all. Okay, look at that heart attack. Okay, never touches the x-axis at all. All right. So, if you have an even degree, you have to have an even number of zeros. Odd degree, an odd number of zeros. Make sense? Everybody good? Okay, let's talk about what you're actually going to have to do with this, all right? So I'm basically going to ask you, I think it's end up going to be 4 questions, all right? Question A, degree. Question B, leading coefficient. C, and behavior. And D, number of zeros. Okay. Those are going to be the 4 questions that you're asked. All right.
So we won't have to really show work.
There's not really any work to show. Okay, so for those of you that hate showing work, this is kind of your lesson. This is all kind of in your head, understanding what you're looking for, no work to show. Okay, and knowing what the answers are. All right, and here's what I mean. For degree, am I looking for a specific number?
No.
No. What am I looking for?
Positive and negative.
No.
No, odd or even.
Odd or even. See, that's what I'm talking about. You got to make sure you keep them straight. Okay? Degree, I'm looking for whether it's odd or even. Leading coefficient, what am I looking for?
Positive.
Or positive or negative. Okay? You're just taking the hypothetical function, a hypothetical graph, and I'm asking you, is it going to be an even or odd degree? You don't know, you won't know what exactly number it is. So for those of you that are going to need an exact answer because you're a little OCD about it, get over it. You won't know what actual degree it is. All you'll be able to figure out is if it's odd or even. Same with leading coefficient, positive or negative. And behavior we talked about, number of zeros, what am I looking for? There I'm looking for a, generalize it a, starts with a, n, number. Okay, there I'm looking for a number. Okay, so let's do 4a together. Okay. You would have to have the graph itself. You would have to have. There's a way, but it's not you guys. Okay, to know exactly what degree it is.
So we can just.
For A, function A, since it points opposite, that tells you it's a odd or even. Odd.
Okay, wait, alright.
Okay, opposite directions means odd. Okay. From left to right, this function is decreasing. Okay, see how it starts up here and then goes down? Okay, from left to right, that function is decreasing. So is it positive or negative? Negative. Okay, since it goes from increasing to decreasing, read it from left to right, it's a negative leading coefficient. All right? Let's go to number of zeros first, real quick. Okay, I'll move it to right here. How many times does this guy cross the x-axis? 3. Okay, 3. Okay, 1, 2, 3, right there. Okay, everybody good? All right, so C. Now, end behavior. Like I said, the first quiz we take, I will probably help you along with end behavior. Okay? Like, here's what I mean by help you along.
Oh,
You fill in the blanks.
So what about on homework? Do you have to write all that?
On your homework, you're going to have to write it all out. Okay? Because it is bookwork and I'm not that nice to you.
Decrease?
Okay? So, as x increases, as our x's are getting bigger, your graph is what?
Getting smaller.
Getting smaller. See how it's pointing down on the right side? So as x increases, the graph decreases. Okay, Chamberlain?
So it doesn't matter how many like arches it has.
In the middle here? Nope.
As long as the arrow wherever the point.
Yep.
Arrow, okay.
It could look like the one it does it could look like right there. It could look like that.
As long as the arrow.
As long as the arrows point the same direction. The only one that's going to change your answer to is your number of zeros. Okay? So last one, as x decreases, the graph is what? Increasing. That's only the weird one. Okay? Because you're trained to read a graph from left to right, and then you're not having to read it backwards on the end. That's when the decreasing one's kind of the tricky one of the group. Okay? Makes sense. I know it's a lot of information. It's not what we usually do, but it's part of the chapter. All right, and it's good stuff to know. All right, everybody good? Yes, do B. Okay, just to save a little time if you're not done, that's all right. But for 4B, so the first question is degree, so odd or even? Even. Okay, both direction. If they both point the same direction, whether the direction's up or down, it's even. Always start with the degree, okay? That's not by accident that I'm asking degree first. Start there, okay? Because that's going to split your options into. It's either odd or even. It's the easiest one to tell. All right? Now, since they both point the same direction, that direction is down, so your leading coefficient is negative, right? Both point down, it's negative. If they were both up, it'd be positive, okay? Everybody good so far with those two? Ron?
Isn't it like how you multiply negatives-ish? No.
No. No. All right. C, I'm going to shortcut and just you guys answer back and make sure we get this right, okay? As x increases, so x is getting bigger, what's the graph doing?
Decreasing.
Decreasing, right? It's going down. As x decreases, the graph is?
Decreasing.
Decreasing, okay? The correlation between the degree and leading coefficients and end behavior is always the same. So every even degree negative leading coefficient polynomial is going to have end behavior like we just said. As x increases, the graph decreases. As x decreases, the graph decreases. That's a lot to remember, though. Okay? That's where I said it's memorization, but it's kind of not. That's a lot to remember in one shot. So if you're going to memorize how you figure out the degree. figure out the leading coefficient, and then read the graph for your end behavior. Make sense? How many times does this guy cross the x-axis? Twice. All right. All right, so page 326, 327, I think is actually where it's at. 35 through 40, 47 through 50, and then number 43. All right?